It's no great test of bullet behaviour, but it is interesting to see. Here's what happens when you shoot a steel target with lead. Here's the splat of a compressed powdered zinc bullet. And this is what happens when you shoot brass.
These bullets are made in Denmark by a genuinely, I guess, obsessive mechanical engineering type person. They're the Nielsen Sonic Hunt bullet. It's been made in the CNC process, turned. They've drilled the end. They've put 3 slots almost halfway down the bullet, and they've put a little brass plug in the top. This means it isn't relying on hydraulic expansion. It isn't relying on hitting a water-based thing, which is really incompressible, to initiate the expansion. It's relying on this brass plug to force these 3 blades apart. Now in my hand, I have the result of that. And what you normally get with these is you get the centre core of the bullet carrying on pretty much straight through the animal, giving us that straight line penetration that we want. But these blades, and there's 3 of them, but I could only find 2 off this bullet, these 3 blades form 3 separate wound channels. They stay fairly close to the core. They don't go off at really weird angles. They stay within about 15 to 20 degrees of the core. And actually, again, it's giving you a partially fragmenting bullet. You can guarantee that's going to carry on giving you penetration. You can also guarantee a lot of energy will be dumped in the front half of the bullet, breaking into 3 separate pieces and the little plug. So again, we have lead-free, expanding ammunition, expands very reliably at lower velocities because of the initiator in the end. And this is another example of some of the fantastic technology that's going into bullets now. A good friend of mine, Ben Heath, started using these because he wanted a slightly harder and faster result, and he wanted fragmentation.
Thank you, Andrew. For more about WMS Firearms Training, go to wmsfirearmstraining.com.